So, hi everyone. I'm presenting something new and fresh this time, a bit different than what I'm usually doing in this channel. And it's called, I don't know, how am I going to call it? Can you solve the circuit, the secret circuit or something like this? Anyway, um, so it's going to be a bit of a new thing. So I'm going to be basically taking guests on the show and people that are involved with quantum computing, and they're going to just be going through a little challenge that I send them out, which is basically um, a small circuit that I implemented in Quirk with a secret gate, and they're going to try to solve that by the idea is to try to turn the qubits of the circuit off. And the first person to go through these is Ethan Hansen. So Ethan Hansen is the host and the author of the Quantum Computing Now podcast that you can find here in the Quantum Daily, but I believe it's mostly available through your traditional and typical podcast services out there. I really recommend the podcast. There's a mixture of things in here. So there's a lot of educational stuff, but there's also really interesting interviews. And he's got quite some interesting interviews with people from IBM so far. So I definitely recommend checking this out. And I mean, let's see. Let's see how Ethan did. So it's the first time he goes through this. He hasn't seen this circuit before. Let's see if he manages. Okay, cool.
All right. So, hello. My name is Ethan Hansen, and I am the host and creator of Quantum Computing Now. If you haven't seen my incredibly gorgeous face before, it's because Quantum Computing Now is a podcast where I go over news, basics, and interviews surrounding quantum computing and quantum information sciences, that sort of stuff. I have been given a challenge here. In this challenge, I am given this black box quantum circuit and little thinking face emoji. I don't know what this does. This is my first time seeing this, and my goal here is so we start out in the all zero state. My goal is to get it back to the all zero state, as seen by these measurements. I haven't played around with Quirk all that much. Quirk is this in-browser quantum computing simulator, I suppose. But I've played around with it some, so I know that on is 1, off is 0. And so the first thing I'm noticing in this circuit is that we have this on state. So I'm going to go ahead and throw an X gate on there, and it's off. Awesome. Other thing I'm noticing is 50% probabilities on all of these, typically related to Hadamards. A Hadamard gate rotates the block sphere from being either straight up or straight down over to halfway in between, so that it's got 50% probability of going to either 0 or 1. So let's try throwing Hadamards. So that does nothing. Obviously, if you've already got it in off and you Hadamard to halfway, that turns it off, though. Okay, so this state was probably already the plus state, which is 0, your 0 ket plus your 1 ket over square root 2. The square root 2 is the normalization. Basically, you want a length of 1, which corresponds to sum of probabilities being 1. Our Hadamard is not doing anything to these two, which is interesting. Apologize for that. Let's see. Let's see if anything else here is going to throw that around. We might need to back up a bit. That's fun. let's back up and see if we can't control not this. So something tells me that because a single Hadamard isn't cutting it, we're dealing with entanglement, which would make sense. If we go like that. Nope. I guess that's just the same thing as the Hadamard because that's always on. That's the same. Interesting. All right, let's put these back. So I'm not quite sure what's going on here other than these are controlled on each other, maybe? Ah, there we are. If I throw another Hadamard there, and I not that, there we go, all off. So, I don't know if this is the most efficient way to solve this. I want to see what's behind this black box, but there we go. Quantum information science, if you know what you're talking about, it definitely helps. Unfortunately, I do not know what I'm talking about, so I don't get any help in that regard. But yeah, if you enjoyed this, getting to see a bit of my thought process behind this, see how I explain things, make sure you go ahead and check out Quantum Computing Now. You can find it wherever you get your podcasts from. Really appreciate this opportunity to come on and say hi and show, like I said, my beautiful face. Yeah, thank you everyone for watching.
Okay, that was it. That was Ethan. I think he did pretty well. If you enjoyed the video, feel free to hit the subscribe button. Basically, subscribe to the channel. You can also support me and support this whole project via Patreon. The link should be below in the subscription, and definitely don't forget to check Ethan's podcast. It's definitely worth a check. And let me know also, by the way, if you like the format and the idea, whether you want to see anyone special on the show. So if there's any person that you'd like to see solving and going through one of those challenges, let me know, and I'll make sure that happens. Okay? Cool. Then stay tuned until the next episode.